Virtual Instruments is the leader in application-centric infrastructure performance management. We provide a full-stack, application-centric view of your infrastructure by applying highly granular, heterogeneous, and agentless monitoring with a massive ingest capability to meet IT infrastructure demands at scale in order to deliver cross-silo correlation and provide actionable recommendations by applying machine learning-based analytics. Next, we'll take a look at a demonstration of the solution. We're starting VirtualWisdom with one of the default templated reports. This is an application workload detail report that shows the read and write workload and the response to that workload. At the top we can see the number of IOs per second and the size of the IOs for both the reads and the writes in the environment. We can see an overview of the health of the compute, the network, and the storage components that support this application. And we can get a little bit more detailed view of the workload from a read perspective. We can see the way that the IOPS, IO size, and megabytes per second trend over time. And below we can see how the response to that workload changes over time as well, looking at both the first response from the array as well as the completion time. And then finally we can see the variables that impact the response time, whether it's more heavily impacted by the rate of the IOs, the size of the IOs, etc. On the health section we can see that we have an application that has an open case. If we click on the widget there, we can click on Show Topology to view the topology of this demo application, the compute, the network, the storage components. We can see there are 8 physical hosts connected to redundant A and B fabric utilizing a pair of storage arrays, and we can see a number of alarms on this. First off, we can see an average response time alarm on the production UCS host. If we drill into that response time alarm, we'll be able to see the applications that are impacted by this host, and we'll also be able to see a set of investigations that walk us through figuring out why is there a response time issue. And in this case, the investigation is titled, "Is there a resource contention issue?" And this investigation tells us how to go about determining if there is a resource contention issue, and if there is, what we should do about it. The investigation is suggesting we run the Event Advisor analytic to first find periods of poor performance and then feed those into the trend matcher. Here we can see this host has 5 distinct performance events, and if we drill in, we'll be able to visualize them. We can see there's an event from 8 a.m. on Monday until 9:17 a.m. and there's an event on Saturday from 9:33 to 10:18 a.m. We can pick any of these events and select the trend match option, which is going to take this very distinct curve here. The performance was fine, it was sub 1 millisecond, and then all of a sudden the performance was not fine anymore. In fact, it spiked up to 50 milliseconds at one point. If we click run, then this VirtualWisdom system will go out and look at every other entity in the system and figure out what changed at the same time. Big bubbles here are a VNX storage array, and we can see that the VNX storage array is correlated when the percent of frames transitioning from a 0 buffer credit state spiked. So did the latency on this application. We can click on any of the bubbles and we can view the trends on top of each other. In green we have the latency of the UCS blade, and in yellow we have the percentage of frames transitioning from a 0 credit state. And we can see that when the storage port begins having flow control issues, the write response time of this host goes up significantly. And when the storage array is done flow controlling, the response time of the host goes back to normal. So we have a good correlation here. And our investigation says in the event of a buffer credit starvation, look at the associated case by clicking on the topology. So if we go back to our case and we look at the topology, then we can see this UCS blade uses the VNX A4 storage port, and we can see the A4 port has a flow control issue. If we drill into that flow control issue, we can, it says, follow the investigations there. So we're going to close out the performance investigation. We're going to open up the flow control investigation. This is titled, "Is there a speed mismatch on a connected HBA?" And it says the common cause for flow control is a mismatch in sender and receiver speed. And we want to look at the topology again. We can see the VNX storage array is connected to the fabric at 8 gig, and we've got a QASX host that's connected at 2 gig. If we drill in, then we can see there are 5 physical hosts in this cluster. 4 of them are connected at 8 gig, and 1 of them is connected at 2 gig. The one that's connected at 2 gig has an alarm on a child, so if we drill in and we look at the virtual machines, we'll be able to see there's a load test virtual machine here that is connected at 2 gig to the VNX storage array. So in summary, we were able to identify an application response time issue that was caused by a flow control issue on our VNX storage array, and we were able to, using a combination of analytics and investigations, narrow down the cause of the flow control issue to a mismatch in the sender and receiver speed. There's an ESX host in our QE cluster connected to the fabric at 2 gig, requesting data from a VNX storage array connected at 8 gig.
Stop guessing, start knowing, and take control with Virtual Instruments Virtual Wisdom, the world's first app-centric IPM platform.